So, in today's video, we'll be discussing from question 1 to question 30 and the type of question that is question 31 to question 40. This type of question is not in our syllabus, so we would just avoid them. So, we would discuss from question 1 to question 30. So, we'll discuss chemistry paper 1, MCQ paper 2015 May June Variant is 11 and the subject code is 9701. In question number 1, the diagram shows a Boltzmann distribution of molecular energies of gaseous mixture. The distribution has a peak level P on the diagram. What happens when an effective catalyst is added to the reaction mixture? So catalyst increases the rate of the reaction by lowering the activation energy. So the activation energy is lowered. That means it moves towards the left and it has no effect on the peak of the curve. So it has no effect on the peak of the curve, and if the temperature increases then the peak of the curve moves to right and the peak height decreases. It is like this curve, but for now just the height of the peak remains the same since the temperature is same and the activation energy moves to left. So the answer is D. Question number 2. Which quantity gives the best indication of the relative strength of hydrogen bonds between molecules in liquid hydrogen halides? So which quantity gives the best indication of the relative strength of hydrogen bond? So hydrogen bond exists between the hydrogen and fluorine, oxygen and nitrogen. But since it mentions about the halogen, so hydrogen halide, so the halide is fluoride. So the hydrogen bond between hydrogen and fluorine. So hydrogen bond is the intermolecular forces of attraction that exists between hydrogen and fluorine. So it also exists between oxygen and nitrogen, but since it is mentioning about halide, so hydrogen and fluoride, so that is HF. So which indicates the best indication of hydrogen bonds in liquid hydrogen halide? So this is liquid hydrogen halide. So what is the best indication of the hydrogen bond? So for the hydrogen bond to break, we need to break the hydrogen bond in liquid hydrogen halide, and as the hydrogen bond breaks, the liquid hydrogen halide converts to a gas. That means it is enthalpy change of evaporation. Since liquid hydrogen halide after breaking the hydrogen bond converts to a gas, so it is the enthalpy change of evaporation. This is not the bond dissociation energy, since the bond dissociation energy is the energy needed to break the bond, that is any random bond, but here we don't break the bond, we break the intermolecular forces, that is the hydrogen bond. Therefore it is wrong. It is not enthalpy change of formation and enthalpy change of solution. So the correct answer is D. Question number 3. Use of the data booklet is relevant to this question. 1 gram of carbon is combusted in a limited supply of pure oxygen. 0.5 gram of carbon combusts to form carbon dioxide. So from the 1 gram, 0.5 forms carbon dioxide and 0.5 forms carbon monoxide. So from 1 gram, 0.5 forms carbon dioxide and 0.5 gram forms carbon monoxide. The resultant mixture of carbon dioxide and carbon monoxide that is formed is passed through excess sodium hydroxide. So as the two gases are passed through excess sodium hydroxide, now as we know that carbon dioxide is the acidic gas. So carbon dioxide is acidic gas, so it reacts with sodium hydroxide, and so no more carbon dioxide is remained at the end of this procedure. So only we get carbon monoxide. So carbon dioxide reacts with sodium hydroxide and thus we get the product as carbon monoxide, and the remaining gas, that is carbon monoxide, is then dried and collected. What is the volume of the remaining gas? That means the volume of carbon monoxide. Since carbon dioxide reacts with sodium hydroxide, so the only gas that is remaining is carbon monoxide. So we need to find the volume of carbon monoxide, and all gases have the volume, all gas volumes are measured at 25 degrees centigrade and 1 atmosphere pressure. So we need to find the volume of carbon monoxide. So what is the volume of carbon monoxide? So first of all, we need to write a balanced equation, that is carbon reacts with oxygen, limited supply of oxygen to form carbon monoxide, and to find the volume of carbon monoxide, first of all we need to find the number of moles of carbon. So we know that 0.5 gram of carbon forms carbon monoxide and 0.5 forms carbon dioxide. So 0.5 forms carbon monoxide divided by its AR, that is 12. So this is the number of moles of carbon So number of moles of carbon is same as the number of moles of carbon monoxide. So we know the number of moles of carbon monoxide, and the volume of a gas is equal to number of moles into molar gas volume, that is 1 dm cube. So the final volume that we get is 1 dm cube. So the answer is A. In question number 4, in oxygen difluoride, fluorine has an oxidation state of -1. So we have given the oxidation state of fluorine, that is -1. So what is the oxidation state of this oxygen? So -1 into 2, that is -2. And to balance this -2, oxygen has an oxidation state of +2. Then oxygen difluoride reacts with sulfur dioxide according to the following equation. So this is the equation for this reaction. What is oxidized and what is reduced in this reaction? So here oxygen has an oxidation state of -2 because there is no information given about this, and so no information is given. That means oxygen in sulfur dioxide has an oxidation state of -2. So -2 and 2 oxygen, that is -2 into 2. So if we calculate the oxidation state of sulfur dioxide, sulfur in sulfur dioxide, it comes to be +4. And here oxygen is -2. So 3 oxygen, that means -6. So sulfur has an oxidation state of +6. And in molecule fluorine, it has an oxidation state of 0. So as we can see that fluorine, its oxidation state changes from -1 to 0. That means it is oxidized. Then for oxygen in OF2, so oxygen is +2, and after the reaction it becomes -2. That means it is reduced. And sulfur is +4 and it becomes +6. That means it is oxidized. So the correct answer is B. In question number 5, use of the data booklet is relevant to this question. The gas laws can be summarized in the ideal gas equation below. So PV is equal to nRT. This is the ideal gas equation. 0.96 gram of oxygen gas is contained in a glass vessel of volume 7 × 10⁻³ meter cube at a temperature of 30 degrees centigrade. Assume that gas behaves as an ideal gas. What is the pressure in the vessel? So to find the value of pressure, we know the value of volume, we know the value of R, that is 8.31, which is constant, and we know the volume. So the volume is 7 × 10⁻³. So volume is 7 × 10⁻³ Then we know the value of temperature, that is 30 degrees centigrade, and we must convert the temperature to Kelvin, that is 30 plus 273. So 30 plus 273 Kelvin, and the number of moles of oxygen is the mass of oxygen divided by mR of oxygen, that is AR of oxygen is 16 and 2 oxygen, so into 2, that is 32, divided by volume. So to find the value of pressure, nRT by volume. So after calculating we get the pressure, that is 10.79 kilopascal, that is C. In question number 6, 1 mole of phosphorus chloride PCl5 is heated to 600 Kelvin in a sealed flask of volume 1 dm cube. The equilibrium is established and the measurements are taken. The experiment is repeated with 1 mole of phosphorus chloride heated to 600 Kelvin in a sealed flask of volume 2 dm cube. So initially the volume is 1 dm cube, now the volume is 2 dm cube, that means the volume is doubled. So the volume is doubled, that means the volume increases. As the volume increases, so concentration decreases, and since the volume is doubled, so concentration is half. Since concentration is inversely proportional to volume, so if the volume is doubled, then concentration is half. And since the concentration decreases, so decreasing the concentration will shift the equilibrium on the side where the number of moles are more. So as the number of moles of gas on the right hand side of the equation are more, so decreasing the concentration will shift the equilibrium on the side where the number of moles of gas are more. So the position of equilibrium moves to right. So the equilibrium concentration of PCl5 is lowered, that means more PCl3 and Cl2 are formed in the second experiment. So the correct answer is B. In question number 7, the standard enthalpy change of combustion of glucose and ethanol are given, that is -2820 and -1368 kilojoules per mole respectively. This is glucose and can be converted to ethanol. So this is ethanol, what is the standard enthalpy change for this reaction? So what is the standard enthalpy change for this reaction? That is delta HR, and since it is standard, so delta HR standard, so this is the standard enthalpy change for this reaction. And to find the standard enthalpy change of this reaction, we have given the enthalpy change of combustion of glucose, that is glucose reacts with oxygen to form carbon dioxide and water, and the energy for 1 mole of glucose is negative 2820. So for 1 mole of glucose, the energy is negative 2820 kilojoules per mole, and for ethanol, the energy is negative 1368 kilojoules per mole. So for this is for watt per mole, that means for 1 mole. So for 2 mole, we have to multiply the value by 2. So this is the standard enthalpy change of combustion. Now what is the standard enthalpy change of reaction? So this arrow and this arrow are pointing in this direction, while this arrow is pointing in the opposite direction. So delta HR plus this value, that is this value, is equal to the arrow on the opposite side, that is this value. After calculating, we get the value of standard enthalpy change of the reaction as negative 84 kilojoules per mole, that is B. Question number 8. In which reaction is the underlying substance acting as a base? So this underlying substance, so what is base? Acid is the proton or the hydrogen ion donor, and base is the proton or hydrogen ion acceptor. So proton or hydrogen ion acceptor is base. So for this reaction, the underlying species is sulfuric acid, so it donates a proton, and since it donates a proton, that means proton donor, and proton donor is acid, this is not base. Then HCN, as you can see that HCN is converted to Cn minus, that means it donates proton, so it is acting as an acid. Then HCO3 minus converts to water, carbon dioxide and NO2 minus. So here also for this species we can say that HCO3 minus converts to water, also HNO3 converts to water. So we will discuss this later. So for option D, we can see that the underlying species donates proton, and so it is a proton donor, and proton donor is an acid, so this is not acting as a base. That means the correct answer is C, where HCO3 minus converts to water, and as we can see that there is 1 hydrogen and in water 2 hydrogen, so hydrogen ion gainer, that is hydrogen ion acceptor, is base. So this species is acting as a base, so the correct answer is C. Question number 9. One molecule of hemoglobin can bind with 4 molecules of oxygen according to the following equation. So hemoglobin reacts with 4 moles of oxygen to form this compound at equilibrium reaction. When the equilibrium concentration of oxygen is this much mole per dm cube, the concentration of Hb and HbO24 are equal. So their concentration are equal when the concentration of oxygen is this value. What is the value of Kc of this equilibrium reaction? So Kc is the concentration of the product by concentration of the reactant, that is Kc is equal to concentration of the product, that is this product, divided by concentration of the reactant, that is the concentration of reactant Hb and oxygen, and since there are 4 moles of oxygen, so 4 becomes the power, 4 moles of oxygen, so it becomes the power, also 1 mole of Hb, so 1 becomes the power, and 1 mole of HbO24, so 1 becomes the power. So this is the expression for Kc. Now to find the value of Kc, we know the concentration of oxygen. So we know the concentration of oxygen, that is 7.6 into 10 to the power negative 6. So this is the concentration of oxygen. We substitute this value. Then when the concentration of oxygen is this value, the concentration of Hb and HbO24 are equal. So we take the equal concentration value as x. To find the value of x, we consider this as x. Because this is an unknown and we don't know their specific value, so we just consider them as x, and we need to find the value of Kc. So to find the value of Kc, as we can see that after substituting this value, the x values cancels each other out. That means the answer comes to be 1 by the concentration of oxygen to the power 4. So this comes the value of Kc, there is 2.99 in 10 to the power 20. So 2.99 is approximately 3. So 3 is 10 into 10 to the power 20. So the answer is A. Question number 10. The double bond between two carbon atoms in an ethene molecule consists of one sigma bond. So this is a sigma bond and one pi bond. So this for ethene molecule. So first of all we draw the structure of ethene, that is C2H4, and the double bond for ethene consists of one sigma bond and one pi bond. So the first bond is always sigma bond and the rest of the bonds are pi bond. That means if the bonds, suppose these are the bonds, then the first bond is sigma and the rest of the three are pi. But for now, for this molecule, the first bond is sigma bond and the second bond is pi bond. Which orbitals overlap to form each of these bonds? So what is the orbital overlap? So for the orbital overlap, sigma bonds, for sigma bonds, we can see that, so which orbital overlap to form each of these bonds? So what is the orbital overlap? So to find the orbital overlap for the sigma bond, so this carbon atom and this carbon atom is sp2 hybridized. Why it is sp2 hybridized? Because the hybridization is calculated by the number of atoms attached, number of atoms attached plus number of lone pairs. So for this carbon, it contains 4 electrons and 4 electrons are involved in bonding, so no lone pair. And how many atoms are attached to this carbon? So 1 atom, 2, 3. So in total 3 atoms are attached to this carbon. So 3 atoms, that means sp2. If there is 2 atom, then sp. If there is 4 atom, then first atom is always s, that is first number is always s, and the rest of the number 3 is p, that is sp3. So for now 1, 2, 3, so 3 atoms, so 3, that is sp2 hybridized. So this sp2 hybridized carbon and this sp2 hybridized carbon forms the sigma bond, that is sp2 hybridized and sp2 hybridized. And sp3 hybridization occurs when suppose this carbon is attached to 4 atoms, that is if let's suppose this is the 4 hydrogen, then number of atoms plus number of lone pairs, so 4 atoms and 0 lone pair, so 4 means sp3 hybridized. So for now it is sp2 hybridized since it is attached to 3 atoms and 0 lone pair, so sp2 hybridized, that is either A or B. And pi bond are formed by the overlap of p orbitals, that is p and p orbitals. So the correct answer is A, as the 2 p orbitals overlap to form the pi bond, therefore the answer is A. In question number 11, the diagram shows a reaction pathway diagram for an endothermic reaction. Which arrow represents the activation energy of the forward reaction? So what is the activation energy of the forward reaction? So activation energy, this arrow is the activation energy for this reaction, and this arrow represents the enthalpy change. So this is the enthalpy change, that is from the reactants to the product, and the activation energy is from this path to the top hump. So the answer is B. And in question number 12, this type of question is related to electrolysis and this is not in our syllabus, so you can just avoid this. In question number 13, the 3 minerals below are obtained from mines around the world. Each one behaves as a mixture of 2 carbonate compounds. They can be used as fire retardants because they decompose in heat, producing carbon dioxide. This gas smoothers the fire. So these are the 3 carbonate compound. What is the order of effectiveness as fire retardant from the base to the ores? So as we know that from the reactivity series of group 2 metals, as they all are group 2 metals, the first is beryllium, magnesium, calcium, strontium, barium and radium. So according to the reactivity series, we can see that, or we know that down the group thermal stability decreases, that means more temperature is needed to decompose, but up the group less temperature is needed to decompose. That means among this compound, the compound that contains magnesium would decompose the most, the compound that contains calcium would decompose after the magnesium, and the compound that contains barium decompose after the magnesium and calcium. So barium calcium, calcium magnesium, and magnesium calcium. So obviously the magnesium calcium compound would decompose faster than barium calcium compound. So magnesium calcium and magnesium calcium compound would decompose faster because down the group the thermal stability increases, that means more temperature to decompose, more temperature theta to decompose. So more temperature is needed to decompose, that means calcium and magnesium compounds are up the group, so they need less temperature to decompose. That's why the best use as the fire retardant could be dolomite or huntite. So it could be either dolomite or huntite, that is B, or dolomite or huntite. So which one is the best? Among these two compounds, we can see that they can be used as fire retardant because they decompose in heat producing carbon dioxide. So they produce carbon dioxide and this gas smoothers the fire. So mainly carbon dioxide is produced that causes the or that is needed for this reaction or this procedure. So among these two compound, which compound produces the most carbon dioxide? So as we can see that both contain carbonate, while dolomite contains 2 carbonate while huntite contains 4 carbonate. So as it contains 4 carbonate, so more carbon dioxide is produced than compared to dolomite. So huntite produces more carbon dioxide that is needed for this reaction. So huntite would be the best since it produces more carbon dioxide, then dolomite, then barytosite, whatever it is. So the answer is D. 14. Which observations are made when a sample of silicon chloride is added to a beaker of water? So silicon chloride reacts with water to form silicon dioxide and HCl. And HCl is an acidic gas that causes steamy fumes. So obviously steamy fumes are observed and a white precipitate is observed since silicon dioxide is a solid. So silicon dioxide is a solid, that's why white solid of silicon dioxide is observed and steamy fumes are observed. So the answer is B. Question number 15. Use of the data booklet is relevant to this question. Which diagram correctly shows the atomic radius of the elements magnesium, aluminum, silicon and phosphorus is plotted against the melting point? So by using the periodic table, we know that magnesium, aluminum, silicon and phosphorus are consecutive elements, and as we go across the period, we can see that the number of electrons increases and so the atomic radius decreases. Therefore, phosphorus has the least atomic radius while magnesium has the highest. So magnesium has the highest atomic radius, this is wrong. Magnesium has the highest atomic radius and phosphorus is the least, this is not the least, so this is wrong. So phosphorus has the least atomic radius and magnesium has the highest. So this could be the answer. Then phosphorus has the least atomic radius and magnesium is the highest. So yes, the answer could be either C and D. And what is the melting point? So this is the graph for the melting point. And for the melting point, we know that silicon has the highest melting point, that is sodium, then magnesium, then aluminum, sodium, magnesium, aluminum, then silicon, then phosphorus, then sulfur, then chlorine. So sulfur, silicon, phosphorus, sulfur, chlorine. So as we know that silicon has the highest melting point, so silicon has the highest melting point. Here silicon has not the highest melting point. So this option is wrong and the correct answer is C. Question number 16. Chlorine is widely used in water treatment plants. Which reaction takes place when chlorine dissolves in water? So when chlorine dissolves in water, it forms HCl and HClO. So HCl and HClO, here HClO is not formed, here HClO is not formed, here also not formed. So chlorine basically dissolves in water to form HCl and HClO. You must remember this, where HClO is used for water treatment. In question number 17, astatine is below iodine in group 7 of the periodic table. Which statement is most likely to be correct? So which statement is correct? So among this statement, sodium acetate and concentrated sulfuric acid reacts to form astatine. Yes, this statement is correct because bromine reacts with concentrated sulfuric acid, that is NaBr reacts with concentrated sulfuric acid to form NaHSO4 plus HBr. Then HBr then reacts with sulfuric acid to form Br2, SO2 and water. So yes, bromine forms Br2, arsen forms I2, Br2. So astatine also forms At2 because down the group the oxidizing ability increases, and down the group the halogens becomes more oxidized. So yes, they becomes oxidized, and you must remember this table or this information, that is sodium iodide reacts with H2SO4 to form NaHSO4 plus HI. HI then reacts with H2SO4 to form I2SO2 and water, then I2H2S and water, then I2 sulfur and water. So these are the three different products that are formed. And for the other statements, potassium acetate reacts with dilute sulfuric acid to form white films of H80. So this statement is wrong because it reacts with concentrated sulfuric acid, not dilute sulfuric acid. Then astatine and KCl react to form K80 and chlorine. This statement is wrong because here chlorine has an oxidation state of -1 and it becomes a chlorine molecule, that is Cl2, with an oxidation state of 0. And this is not possible because chlorine is a more reactive halogen. So more reactive halogen can displace a less reactive halogen from a salt solution. That's why this is wrong. If it is chlorine that displaces astatine, then it would be correct because a more reactive halogen can displace a less reactive halogen from a salt solution. This is the less reactive halogen, so it cannot displace a more reactive halogen from a salt solution. That's why it is wrong. Then silver acetate reacts with dilute aqueous ammonia to form a soluble complex. So silver acetate solid reacts with dilute aqueous ammonia. We cannot confirm this statement fully because this type of question is not in the syllabus for AS level. So question number 18, Mohr's salt is a pale green crystalline solid which is soluble in water. It contains two cations, and one of which is iron 2 plus and one of the anion is sulfate. The alinity of the second cation was determined by heating the salt with aqueous sodium hydroxide. A colorless gas was evolved which readily dissolves in water, which giving an alkaline solution. So the gas gives an alkaline solution. A green precipitate was also formed. What are the identities of the gas and the precipitate? So as the gas gives an alkaline solution, so it can be ammonia, but it is not sulfur dioxide because sulfur dioxide gas is an acidic gas, so it gives an acidic solution, not an alkaline solution. That's why it can be either A or B. Then green precipitate is formed, and green precipitate is formed by iron 2 plus and sodium sulfate. For sodium sulfate, no green precipitate is formed, so the correct answer is A. Question number 19, use of a data booklet is irrelevant in this question. Which mass of solid residue will be obtained from the thermal decomposition of 4.10 gram of anhydrous calcium nitrate? So anhydrous calcium nitrate decomposed to form calcium oxide, nitrogen dioxide and oxygen. So you must remember this balanced equation. So which mass of solid residue is formed? So which mass of calcium oxide is formed? So we need to find the mass of calcium oxide. So to find the mass of calcium oxide, we need to know that mass in grams is equal to number of moles into AR or MR. So we can find the MR, but what is the number of moles? So number of moles of calcium oxide and calcium nitrate are 1:1 ratio. So what is the number of moles of calcium nitrate? Calcium nitrate moles, we know the mass of calcium nitrate. So mass in grams divided by MR of calcium nitrate, we get the number of moles of calcium nitrate, and this is same as the number of moles of calcium oxide since they are 1:1 ratio. So we know the moles of calcium oxide. So we find the MR of calcium oxide, that is calcium is 40 and oxygen is 16. So 40 plus 16. So what is the mass? Mass in grams is equal to number of moles into AR/MR. So the total mass comes to be 1.4 gram. That is answer C. Number 20. Which reagent will give a different observation with compounds P and Q? So which reagent gives a different observation? So if we draw the structure of P and Q, then P would be OH, CH2, then CH, OH, COH. So there is an aldehyde and an alcohol functional group, two alcohol functional group. Then for Q, OH, CH2, then CO, that is ketone, then CH2OH. So this is the structure of Q. And bromine. So aqueous bromine. So aqueous bromine is used when to determine the carbon-carbon double bond, and it changes color, or it changes color from orange to colorless, or it is decolorized. But since there is no carbon-carbon double bond is present, so this statement is wrong. Then hot acidified KMnO4. So hot acidified KMnO4 oxidizes the alcohol and the aldehyde, and KMnO4 changes color from purple to colorless, so it can oxidize this compound. Here also alcohol is present, so it can oxidize this compound. So this is not used to differentiate them, since it changes color from purple to colorless in both of these compounds as they are oxidized. That's why this is wrong. Then silver nitrate in aqueous ammonia. So silver nitrate in aqueous ammonia, you have to remember that silver nitrate in aqueous ammonia is a tolerance reagent. So this is an important point, that silver nitrate in aqueous ammonia is a tolerance reagent. That is, silver nitrate in aqueous ammonia is a tolerance reagent. So tolerance reagent is used for the identification of an aldehyde. So yes, aldehyde is present, but there no aldehyde is present, so it can be used to differentiate them, and tolerance reagent produces a silver mirror in the presence of an aldehyde. So yes, aldehyde is present, so it can be used to differentiate between these two compounds. Then warm acidified K2Cr2O7. So it also causes the oxidation. That's why alcohols are oxidized, and this one aldehyde is also oxidized to form carboxylic acid, while their alcohol is also oxidized. So yes, both of these would be oxidized, and so it cannot be used to differentiate them. That's why it is wrong. So the correct answer is C, that is tolerance reagent or silver nitrate in aqueous ammonia or ammonia solution is used to differentiate between these two compounds, because silver nitrate in aqueous ammonia solution is the tolerance reagent that is used for the identification of aldehyde. Question number 21. The cyclic compound M is heated with dilute hydrochloric acid. What are the products of the reaction? So it is heated with dilute hydrochloric acid. That means HCl is present. Also water is present. That means as HCl and water is present, that means it is an acidic hydrolysis reaction, and this ester is hydrolyzed to form this compound. So this is the compound that is formed after the hydrolysis of the ester. So as this compound is formed, we can see that the ester at this point breaks and carboxylic acid and alcohol is formed, and this is the compound that is mainly formed. Now for this compound, for these options, we have to find the compound that contains carboxylic acid and alcohol. So this contains alcohol and an aldehyde. There is no carboxylic acid, that's why this is wrong. Then in this option alcohol is present, then aldehyde is present but no carboxylic acid, that's why this is wrong. Then the answer could be either A or B, and for A and B there is carboxylic acid present, then carboxylic acid present, then so for option A and B, for option A and B, carboxylic acid is present, then OH is present, and CH2 is present, that means they both are the same compound. Then for this compound, carboxylic acid, CH2, just the difference is that in compound A there is NH2, while in compound B there is ammonia 3+. So which option is correct? Now NH2 reacts with the hydrogen ion that is present in the compound to form ammonia positive ion. That's why the answer is B. And this type of question is now in A2 syllabus, not in AS level syllabus. So if you think you can avoid this, just NH2 reacts with hydrogen plus ion to form ammonia. That's why the answer is B. Question number 22. Oil contains large amount of polyunsaturated carboxylic acid. When this oil is used to make margarine, the carbon-carbon double bond in the unsaturated carboxylic acid are hydrogenated. Which reagent and the condition would be suitable to bring about this hydrogenation reaction? So what is the hydrogenation reaction? That means the carbon-carbon double bond or the alkene reacts with hydrogen in presence of platinum or nickel catalyst and heat to form an alkane. So alkene reacts with hydrogen, that is the hydrogenation, in presence of platinum or nickel catalyst and heat to form an alkane. You must remember this reaction. So which reagent in the condition? Hydrogen gas is needed, and nickel or platinum catalyst is needed, and heat, so high temperature. So the answer is A. In question number 23, which intermediate ion forms in the greatest amount during the addition of HBr to propene? So propene, that means carbon-carbon double bond is present, and METH, ETH, propene. So which intermediate forms the greatest amount? So when HBr reacts with this compound, so the intermediate that is formed in the greatest amount is the intermediate that contains most number of alkyl groups, or the carbocation that is attached to more number of alkyl groups. So this carbocation that is attached to 1 and 2 alkyl group by the addition of hydrogen to this CH2. So this carbocation is the most stable since it contains 2 alkyl group, while the other carbocation that is formed, that is CH2, CH3, then CH and CH2. So here hydrogen is attached and this carbocation is formed, and this is the least stable because it contains the carbocation is attached to less number of alkyl groups. So the first one contains 2 alkyl groups, so yes, this is the option that is correct. For the second option, here the second compound is drawn, that's why it is wrong, because the carbocation is attached to less number of alkyl groups, so this is wrong. Then for the third answer, we can say that first of all H is attached, so this is wrong, this is also wrong. So the correct answer is A. In question number 24, choline is a major constituent of the poison of oil of hemlock. Choline can be synthesized by reacting ammonia with the dibromo compound X. So ammonia reacts with the dibromo compound X to form choline and HBr. What is the name of compound X? To find the name of the compound X, we have given the name of the choline, and for this compound we know the structure of choline, but what is X? To find the X, first of all, if you just compare, then as we can see that in choline there is no Br, but X contains 2 Br, and X contains 2 Br, and there is no ammonia but it contains NH. So if we just remove this NH, since there is no NH in X, and if we add 2 Br, that is in both the hands 2 Br, that is like this compound, so this could be the possible structure of X. So for this structure we have to count from the most number of bromine. So 1, 2, there is METH, ETH, prop, but, pent, hex, hept, oct. So this is octane, and this is 1, 2, 3, 4, 5. So 1, 5 dibromo-octane. So the answer is D. Number 25, 2-bromopropane. So 2-bromopropane, that is METH, ETH, propane, and 2-bromopropane. Okay, it reacts with hot concentrated solution of sodium hydroxide in ethanol. So hot concentrated sodium hydroxide in ethanol. So basically sodium hydroxide in ethanol causes elimination, that means elimination of HBr. But if it is sodium hydroxide in aqueous, then it causes addition of OH group. But now since it is sodium hydroxide in ethanol, so HBr is removed, so hydrogen is removed from one carbon, so Br is removed from one carbon and hydrogen is removed from the adjacent carbon, that is either this carbon or this carbon. So we remove hydrogen from this carbon and a double bond is formed. So this is the structure of the final product, that is METH, ETH, prop. So propene, that is D. Number 26, the presence of a halogen in an organic compound may be detected by warming the organic compound with aqueous silver nitrate. Which compound would be the quickest to produce a precipitate? So which compound would be quickest to produce a precipitate? That means which compound would react with aqueous silver nitrate to form a precipitate. And as we know that down the group the reactivity decreases of the halogen, that is fluorine, chlorine, bromine, iodine and astatine. So fluorine is more reactive, so since it is more reactive, so the bond with carbon is more with fluorine, so this bond is difficult to break. Then the chlorine with carbon, the bond is weaker than fluorine, and the weakest bond is iodine. So which compound will produce the quickest precipitate? So the answer is C, because the carbon fluorine bond is strongest, so it is not broken, but the carbon iodine bond is the weakest, so this bond is broken and the precipitate is formed. Therefore the answer is C. And in all other options no iodine is present, so it will take time to break the bond, since down the group reactivity of the halogen decreases, Therefore, the carbon-iodine bond is the most or the first to break. As the carbon-iodine bond breaks, so it reacts with silver nitrate to form a yellow precipitate. That's why the answer is C. Question number 27. Which agent will give a different observation with compound W and X? So if you compare W and X, then W contains a carbon atom that is attached to OH group. So the carbon atom that is attached to OH group is attached to one carbon atom. So this is a primary alcohol. While for X, the carbon atom that is attached to OH group is attached to three other carbon atoms. So this is a tertiary alcohol. So this is a tertiary alcohol, while this carbon atom is attached to one alkyl group. So this carbon atom that is attached to OH group is attached to one carbon atom. So this is a primary alcohol. So primary alcohol can be oxidized, while tertiary alcohol cannot be oxidized. So we need to find an oxidizing agent, that is hot acid K2Cr2O7. So this is an oxidizing agent that causes the oxidation of primary alcohol, but tertiary alcohols are not oxidized. Therefore, the answer is B. Question number 28. In 1869, Ledenberg suggested a structure of benzene for benzene, that is C6H6, that is this structure C6H6, in which one hydrogen atom is attached to each carbon atom. There is one carbon is attached to one hydrogen, and this is the overall structure. Then a compound C6H4Cl2 could be formed with the same number of carbon skeletons as Ledenberg structure. So the overall structure remains the same, just instead of this any of these two hydrogen, two chlorine atoms are replaced. That is, two chlorines are replaced. How many structural isomers would this compound have? So how many structural isomers would this compound have? So first of all, to draw the number of structural isomers, the answer should be 3, because this is one of the structural isomer, then this one is another structure. So this is not the structure, because if we see that the structure, then ClCl, they are the same. So this structure is wrong. That's why the second structure is ClCl, and the third structure would be crisscross, that is Cl on this carbon and this carbon. So this is the overall structure for the number of structural isomers. And if you try to draw more structural isomers, you cannot draw this, because only this type of structural isomers are formed, and this is a really critical question. Question number 29. The citrus flavor of lemon is due to compound limestone present in both peel and the juice. What is the mole ratio of carbon dioxide to water produced when limestone is completely burned with oxygen? So number of moles of carbon dioxide and number of moles of water. So what is the number of moles of carbon dioxide and water? So for this structure, if we draw this structure in this way, then this structure contains 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 carbon, that means carbon dioxide is formed. So 10 carbon dioxide. So total carbon dioxide that is formed is 10. And what is the number of moles of water? So this carbon contains, okay, so this carbon is attached to 1, 2 and 3 hydrogen. This carbon is attached to 1, there is 1 hydrogen, then 1, 2, then 1, 2, then 1, 2, then 1, then 1, 2, 3, then this carbon atom is full, then 1, 2. So 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So in total 16 hydrogen, that is water is formed. So 8 water. So if we calculate the ratio, then 10 is to 8, that is 5 is to 4. So the ratio is 5 is to 4. That is carbon dioxide is to water is 5 is to 4. That is B. Question number 30. What is the organic product of when this compound is boiled with excess aqueous sodium hydroxide? So when this compound is boiled with excess aqueous sodium hydroxide, then what is the product? So CH3CONH2. So this compound, that is CH3CONH2. Okay, we have to go through each of these answers. Then CH3CN, is this possible? So CH3CN, this structure is not possible because this compound reacts with sodium hydroxide. So CH3CN is not the possible product, because this is not possible because CH3CO is have to present. Then CH3CO ammonium. So CH3COO ammonium, this is also not the product, because CH3COO Na have to be present, because Na is a positive ion. So this is wrong. Then this structure is also wrong, and the closest answer that we can assure that is option D, because CH3CO, then ONM and NH3 is also formed. So the correct answer is D. That is the closest answer. So the answer is D.